In this lesson, we're going to again look at completed square form, but in a slightly different form, this time with a bracket at the end, and importantly a negative in front of the bracket. The 2 is also in a funny position. It was at the end before and it's now at the start. Let's have a wee look at this and how it pans out and see what happens. So the first thing I'm going to do is just make sure it is a quadratic, and I'm going to times it all out and show you what happens. So let's multiply all this out. So if we leave the 2 there, leave the negative, and just think about timesing this bracket out, because that's what that means. X minus 3 squared means x minus 3 times x minus 3. Again, if you leave the negative in front of the bracket and you do it, that's going to be x squared. You're going to get minus 3x, and plus 9. So that's going to go to that, to minus 6x, and then plus 9. Now if you times this through by the negative here, you get negative x squared, negative times negative plus 6x, and then take away 9. So it's going to look like that to some degree. If we just simplify that and kind of click things up, then it's going to look like this. Negative x squared plus 6x minus 7. Now this is different to before. Before we had a plus x squared when we would times the bracket out. Now we've got a negative x squared. So that gives us a maximum turning point. So when we see completed square form in this format with a negative in front of the bracket, that's given us a maximum. So if we try and remember back to this idea here, positive x squareds, like coefficients that are positive, they give a minimum turning point. That's a low point here. And negative x squareds, even negative 3 or negative 4, but negative values in front of x squareds give maximum turning points. Other things we have to remember is that these bits are the roots where the graph cuts the x-axis, and also make sure you understand the line of symmetry. It's called an axis of symmetry. It's basically just a line of symmetry, and that happens at the x value of the turning point. In this case, x is 2. And you've got the same thing over here. There's the roots where it cuts the x-axis, and you have a maximum turning point here, and it's at 0. So the axis of symmetry, x equals 0. Okay, so imagine we were asked to find where the turning point was. In the next lesson I'm going to look at sketching them. But imagine you were trying to find out where the maximum turning point happens. So like before, the maximum turning point occurs when the y coordinate is at its, slightly different here, biggest and not smallest. It's a maximum that goes up and back down, so it's where the y value is at its highest. Now because you've got a takeaway here, we still want this to be the lowest possible it can be. The reason for that is because we want to take away the least value to leave the biggest value for the y. So I'm still trying to make this 0, because when you square the function, anything negative will become positive. So the lowest value this can take is 0, and that's going to happen at 4. So it's very similar to what happened before. So an x value of 4, and that's going to leave us with a high y value of 5. Okay, so that's very similar to before. I create the x value that makes it smallest in this kind of green oval, and then this is your y value, because that's what you're taking away, 0 basically. Now if you were to draw it, it would look like this. There's the turning point at 4, 5. There's your axis of symmetry at x equals 4. Okay, I'll just look at some examples of this. So this is something you could put in your note. Any quadratic in the form y equals b minus x minus a squared. Or you could see it like this. The b could be placed at the end with a negative in front of the bracket. That's just a rearrangement of this. It's got a maximum turning point at the value a, b. Okay, we'll look at 3 examples. So here's the first one. We're trying to find out where the turning point is at. Now, try and make the bracket part equal to 0. That gives your x value, which is in this case is 4, and that's going to leave you with a 1, because this is going to go to 0. So it's going to be 1 take away 0. So it'll be 4, 1, and that will be where your turning point is. Now your axis of symmetry line is just where the x value is of the turning point, so that's just x equals 4. On to the next one. So I'm looking for the turning point here, the maximum turning point. I'm trying to make the bracket bit equal to 0. So that happens when x is 6. So you'll be taking away 0 from minus 2. So it's 6 minus 2. And the axis of symmetry is just where the x value is. It's a vertical line. It's just called x equals 6. Okay, last one here. We're trying to make the bracket equal to 0, just like all the other ones. And that happens at x equals minus 3. And that's going to make that 0. So you're going to have 2 take away 0. So it's just minus 3, 2. And the symmetry line is where the x value is. X equals minus 3.